This integral is a great integral to consolidate your understanding in integration because it uses various techniques of integration. For example, integration by substitution, as well as integration by parts. So let's jump straight into it. So we have the integral of arc sine of ln of x over x dx. So it's quite obvious to substitute in u for ln of x because we know that the derivative of ln of x is 1 over x, and we're going to make a good substitution here for 1 over x dx to be du, and we can see that immediately. So we go ahead and make that substitution. So we have u equal to ln of x, so therefore du is equal to 1 over x dx, and then we substitute that into the integral, and we get arc sine of u du. Alright, now we need integration by parts to integrate this integral. So, or rather, let's not do an equal. We say now s is equal to the part that's going to be easy to differentiate, which is going to be arc sine of x. And then we'll have dv being the part that's easy to integrate, which is just going to be 1 du, or just du. So integrating arc sine of x, we get 1 over the square root of 1 minus x squared dx. And sorry, these should be u's here. So 1 minus u squared du. So now v is also going to be equal to u. Okay. So now we go ahead with this integration by parts, and we have s times by v, which is u times by arc sine of u, minus the integral of v ds. So that's u over the square root of 1 minus u squared du. So now we notice that the derivative of u squared is going to be 2u, and we have a u here in the numerator. So we'll make a substitution here. So let's say 1 minus u squared is equal to r. Therefore, dr is equal to negative 2u du. Then we can take this negative 2 across, because we're going to be substituting in for u du. So we have negative 1 over 2 dr is equal to u du. So continuing with this integral, we have u arc sine of u minus the integral, and now for u du, we're substituting in this, which is going to be negative 1 over 2 dr, and then for 1 minus u squared, we're substituting in r. So we have the root of r, and the root of r is the same as saying r to the power of 1 over 2, and r to the power of 1 over 2 in the denominator is the same as r to the power of negative 1 over 2 in the numerator. And now we have a negative 1 over 2 here that we can take out of this integral, because we can take constants out. So we can get rid of this here, and then take this negative 1 over 2 out, and then this here becomes a plus, because a negative times a negative is a positive. So now I can move along with this integral, and we have u arc sine of u plus 1 over 2, and then r goes to r to the power of 1 over 2, and then 1 over 2 divided by 1 over 2, and now these two cancel out and just become 1, and plus c. So now we substitute everything back in to get our actual integral. So for r here, we're going to substitute in 1 minus u squared. So let's go ahead and do that. So we have u arc sine of u plus 1 minus u squared, and that's the square root of that, plus c. So now for u, originally, we made it equal to ln of x. So now we substitute in ln of x every time we see a u. So we have ln of x times by arc sine of ln of x plus the square root of 1 minus ln of x squared plus c. And that's the integral solved. Hope you enjoyed this video, and I hope you found it useful because it does really recap all the important and fundamental techniques of integration that you're probably going to find yourself using a lot. And I hope you did enjoy it too. And if you did enjoy it and learned something from it, please don't hesitate to leave this video a like and subscribe. Thank you.